we will see another problem. A circular disc, this is from tutorial 4, problem number 4.9. A circular disc of radius A. So let us first draw this as a circular disc. Okay, this is the circular disc, and the circular disc is having the radius A. This is the radius A. So the radius is equal to A, and it carries the charge of 1 over rho coulomb per meter square. So rho is nothing but it's the radius axis. So you can see here the rho is changing from 0 to rho equal to A. Okay, so it is representing the axis for the radius actually. So you see here along rho the charge density, along rho the charge density is like the surface charge density is equal to 1 over rho. So the surface charge density is given as 1 over rho. Now calculate the potential at 0, 0 h. So this is at point 0, this is at the point which is 0. So let us first draw the axis for this. So I will use the next page. So let us consider the z axis, x axis and the y axis, and next we will draw the circular disc which is placed on in the xy plane. Okay, now this is your component which is rho, which is changing from rho equal to 0 to rho equal to A. So this is the radius. Okay, this is the radius. Now there is some point here which is 0, 0 h. We want to find what is the potential at this point. What is the potential? So we will first take a small component, some small component here which is ds. So the charge at ds will be dq. It is having the charge dq. Okay, the charge at ds is given as the surface charge density multiplied with ds, and you know that this is a circular disc. So we will consider this as the parameter rho, and this is the phi. So in terms of that we can write ds as rho into d phi into d rho. So this is ds. So that we have already seen in the while teaching the cylindrical coordinate system. Now you can get dq as, what is our rho s? It is given that rho s is equal to 1 over rho. So rho s is equal to 1 over rho into d phi d rho. So this you will get as d phi into d rho. Okay, now we want to find what is the potential at the point 0, 0 h. So the potential at the point 0, 0 h due to this small charge dq is given as this guy. That means this charge will create a potential at the point 0, 0 h, and that potential is given as dv. Okay, the distance between them, this ds, is given as, let us assume that this ds is at position, let's say the ds is at position, is better to denote with the axis. So this is at position, this is at the position as shown here, and so we will get the distance from the origin. Distance from the origin to this point is rho. Okay, and the angle as phi. Okay, the angle as phi. Okay, now you see the distance is rho and the height is h. So the distance from ds to the point 0, 0 h is given as rho square plus h square, and you have to take the square root of it. So that will give you the distance. Now you can calculate the small potential or the voltage due to this small charge dV, that is, this is due to small charge dq at the position at ds, as shown in the figure, okay. So this is given as the small charge is dq divided by 4 pi epsilon 0, and the distance, what is the distance? The distance is nothing but, this is the distance, okay. The distance is nothing but the square root of rho square plus h square, okay. So this is the distance. Now to find the total voltage, to find the V, we have to integrate dV over the whole surface, okay, because this is a circular disc, so it has the surface area S, okay. So we have to integrate over the whole surface area, then we will get the total effect. So what you have to do, V is equal to integral dV over the whole surface. Now we have to integrate dV. What is dV? We have already seen dV is equal to dq. So what is dq? Dq we have to substitute here. So what is dq? Dq is given as d phi into d rho divided by okay, divided by 4 pi epsilon 0 into square root of rho square plus h square. But there are, to find the surface area, we have two variables. One variable is phi changes from, one variable is phi changes from 0 to 2 pi, and another variable is rho changes from 0 to at the center of the disk to the maximum, that means the radius. So at radius rho is equal to a, so rho is equal to a, okay. So rho changes from 0 to a, so I will just write rho changes from 0 to a. Now first we will integrate over phi, so V is equal to integrate rho changes from 0 to a, and then 1 by 4 pi epsilon 0 square root of rho square plus h square. Then we have phi, integral of d phi is phi, then we have d rho, phi changes from 0 to 2 pi. So we will get V as 0 to integral rho changes from 0 to a 2 pi divided by 4 pi into epsilon 0 square root of rho square plus h square, okay. Then we have into d rho. Now you can cancel out some terms. You see 2 pi divided by 4 pi, this become 2. So this you will get it as 1 by 2 epsilon 0 integral rho changes from 0 to a, okay, d rho divided by root of rho square plus h square, okay. So what is the integral of rho square, d rho divided by rho square plus h square? So I will give you a formula. So remember this formula. I am not going to prove it. Integral dx divided by root of x square plus h square is given as ln, okay, natural logarithm, the modulus of x plus root of x square plus h square, okay. So this is the integral. So this formula is a general formula, so we will apply this result. Instead of x we have rho, so we will get our voltage as 1 by 2 epsilon 0. Then we will get d rho by rho square plus h square, the integral as ln, the magnitude of, instead of x we have rho plus root of rho square plus h square, okay, rho square plus h square. So we will get then we have to apply the limit. What is our limit? Rho changes from 0 to a. So V is equal to 1 by 2 epsilon 0 ln, okay, ln of first if I apply rho is equal to 0, then this becomes 0 plus root of h square, or 0 plus h square. Then sorry, first I will apply the upper limit, sorry for this. So ln of, if rho is equal to a plus root of a square plus h square, okay, then minus ln of 0 when rho is equal to 0, ln of 0 plus root of 0 square plus h square, okay. So this you will get as the final answer as, so V is equal to 1 over 2 epsilon 0 logarithm ln of, you see here it is in the form of ln of a over b. So ln of a plus root of a square plus h square divided by h, okay, because this the whole term this become h. So this is the final form. So I hope this is clear to you. Okay. Thank you.